Now, dear student of class 12, I'll start with, I've already done partial fraction. We did partial fraction in the last video, but it's a second part of the partial fraction. Now, this is another type of numerical. Now, try to understand this numerical. Now, say we in this numerical, x square over x minus 1 into x minus 2. Now, say how to tackle this kind of question. We cannot use directly partial fraction over in this question. Now, say the index of numerator, the higher index of numerator is x square, and if you multiply the denominator, what you will get? X square, quadratic equations that you will get. Now suppose the higher index of numerator and the higher index of the denominator is same, we cannot use directly partial fraction. So how to apply partial fraction in such kind of question? That you have to divide first. Now say I'll do this particular question but in a different method. Now I'll write x square plus x over, first of all I'll multiply these two, x square minus 2x minus x plus 2 dx. Now then it is x square plus x over x square minus 3x plus 2 dx. Now this step is very important, dear student. This step is important. Now say try to adjust this denominator in the numerator. I'll write first. Now say the easy method is I'll write the entire quantity of denominator in the numerator. The denominator is x square minus 3x plus 2. The same thing I'll write in the numerator, x square minus 3x plus 2 in the numerator, divided by x square minus 3x plus 2. The same thing I'm going to write, but in the numerator it's supposed to be x square plus x, but I'm writing x square minus 3x plus 2. By addition or by subtraction, I'll try to adjust this quantity in terms of this. X square is there, in place of x, I've written over here minus 3x. So if I write plus 4x, now say minus 3x plus 4x is x, and as well as extra 2 is there, so minus 2. And you just simplify this numerator, you'll get x square plus x. Indirectly I'm writing x square plus x over here. 3x plus 4x is x, plus 2 minus 2 get cancelled. Now after the simplification you'll get x square plus x. This is a method that you have to adjust denominator in numerator. Now then after getting these things, now then I'll I'll divide the integral separately. I'll divide this one, x square minus 3x plus 2 divided by x square minus 3x plus 2. I'll divide this entire quantity by this denominator. Then we'll get 1 plus 4x minus 2 over x square minus 3x plus 2 dx. Now then I'll separate the integral. It is integration dx plus integration 4x minus 2 over x square minus 3x plus 2 dx. Now the integration of dx is x, plus 4x minus 2 over, in place of this quadratic equations, this quadratic equation we can replace it by the fraction. It's factor x minus 2 dx. Now the second integral, first is x, integration of x is dx is x. The second integral is in terms of linear over linear form. So I'll consider this one is x plus this entire integral, I'll represent it by I. Let it be equation number 1. Then therefore I is equals to integration of 4x minus 2 over minus 2 dx. Now over here we can apply partial fraction by previous method. Now I'll write 4x minus 2 over x minus 2. So it is a over x minus 1 plus b over x minus 2. After LCM we'll get 4x minus 2 is equals to a into x minus 2 plus b into x minus 1. Now you know about the method. Now how to calculate the value of a and b. Now then, to calculate the value of a, you have to make b quantity 0. How to make b 0? If I consider x equals to 1, 1 minus 1, 0. B, entire b quantity will be 0. Then we can calculate the value of a. So it is 4 into 1 is 4 minus 2 is equals to a into 1 minus 2 plus 1 minus 1. This one will be 0. It is 2 is equals to minus a. This is 0. Therefore, the value of a is minus 2. Similarly, to calculate the value of b, we have to make a quantity 0 by consideration of x. So if I consider x equals to 2 plus 2 minus 2, it will be 0. Now then substitute over here. 4 into 2 minus 2 is equals to a 2 minus 2, 0. Then plus b into 2 minus 1. 4 2s are 8. 8 minus 2 is 6. Then this one is 0. B is equals to 6. Therefore, the integration is I is equals to, substitute the value over here. A is minus 2 over x minus 1. B is 6 over x minus 2 dx. Now minus 2 integration dx over x minus 1 is log of x minus 1 plus 6 log of x minus 2 plus c, the value of I. Now putting the value of I in equation number 1 over here, putting the value of I in equation number 1 over here, that you have to substitute. Putting the value of I in equation 1, then we'll get proper integral. X, the value of I is minus 2 log x minus 1 plus 6 log of x minus 2 plus c. This is your final answer. This method is applicable if the index of numerator and the index of denominator is same. Now dear student, another question is question number 24. It is similar to the previous one. One more questions I'll do. Now say over in this question also, the index of the numerator is x square, and if you multiply the denominator, what you will get? The higher index is x square. In this case, the method is, what you have to do is, you have to adjust its denominator in the numerator. First of all, that you have to multiply these two quantity. It is x square minus 3x minus x plus 3 dx. Then it is x square minus 3 over x square minus 4x x square minus 4x plus 3 dx. Now then, I'll write the entire denominator in the numerator to adjust this numerical. The denominator is x square minus 4x plus 3 whole divided by x square minus 4x plus 3. Now then, I'll convert this x square minus 4x plus 3 in terms of x square minus 3. Now say x square is already there, minus 4x is extra, so I'll write plus 4x, so that minus 4x plus 4x get cancelled. Plus 3 is there, but what we required? Minus 3, so I'll write minus 6. Now try to simplify this one. Now say x square minus 4x plus 4x get cancelled, and 3 minus 6 is minus 3. Indirectly we are getting, in this equation, indirectly we are getting x square minus 3 dx. Now then divide. I'll divide this two. X square minus 4x plus 3 divided by x square minus 4x plus 3, it will be 1 plus 4x minus 6 over x square minus 4x plus 3 dx. Now then integration We'll separate the integral dx plus integration 4x minus 6 over x square minus 3x plus 4x plus 3 dx. So integration of dx is x plus. Now then we can write this is equals to 4x minus 6 over this quadratic equation we can write in terms of its factor x minus 1 into x minus 3 dx. Now then the second integral I'll consider x plus this entire integral equals to I, and let it be equation number 1. The similar method I'm doing over here. Now the I is equals to I is 4x minus 6 over x minus 1 into dx. Now then use partial fraction. Then it is 4x minus 6 over x minus 1 into x minus 3 equals to a over x minus 1 plus b over x minus 3. So take LCM. After LCM we'll get 4x minus 6 equals to a into x minus 3 plus b into x minus 1. You know about the method to calculate the value of a, that you have to make the b quantity 0 by considering the value of x. Now I'll consider x minus 1 means x equals to 1. 4 into 1 minus 6 equals to a is equals to 1 minus 3 plus b quantity will be 1 minus 1 0. 0 into b is 0. It is minus 2 is equals to minus 2a. Therefore the value of a is 1. Same way I'll consider the value of x, so that we'll try to make a quantity 0. So it is x equals to 3. 4 into 3 minus 6 equals to a into 3 minus 3 plus b into 3 minus 1. You get 0. 4 3s are 12. 12 minus 6 is 6. It is 3 minus 1 is 2. It is 2b. Then b is equals to 3. After getting a and b, now then integration. Therefore I is equals to the value of a is 1. 1 over x minus 1. b is 3. 3 over x minus 3 dx. Now the integration of dx over x minus 1 is log of x minus 1 plus 3. Integration dx over x minus 3 is log of x minus 3 plus c. Now this one is the value of I. Putting the value of I in equation 1, that will get the final answer. Therefore x plus, and the value of I is log of x minus 1 plus 3 log of x minus 3 plus c is the final answer. Now next question is question number 31. Now in this question we'll discuss the method of substitution, then integration by partial fraction. Method of substitution. Now say over here the substitution quantity, derivative of x square is 2x. So I'll consider let x square equals to z. Then the derivative of x square is 2x dx is equals to dz. Then x dx is equals to dz by 2. Therefore the integration would be dz by 2 over z plus 1 into z plus 3. Now it is 1 by 2 integration dz over z plus 1 into z plus 3. Now then easily we can apply the partial fraction over in this case. Now the partial fraction will be, in this case the partial fraction will be 1 over z plus 1 into z plus 3. Then the application of partial is the same, e over z plus 1 plus b over z plus 3. Now then take LCM. A into z plus 3 plus b into z plus 1, the partial fraction. Now then you have to calculate the value of a and b. I'll consider z equals to minus 1. Minus 1 plus 1, it will be 0. Then over here, what we'll get? 1 is equals to, if I substitute minus 1 plus 3 is 2. 2a. Then the value of a is 1 over 2. Similarly, I'll consider z equals to minus 3, so that we can calculate the value of b. 1 is equals to minus 3 plus 3, 0. Then this one will be minus 3 plus 1. It is minus 2b. b is equals to minus 1 by 2. Therefore, the integration. And you just remember, if there are some coefficient in integral, you just have to mention over here. Now say the coefficient of integral, any constant term is half. So I'll write first half, then substitute the value of a. Half over z plus 1 plus b is minus half over z plus 3 dz. Then this one will be half, within bracket half, integration dz over z plus 1 is log of z plus 1. Minus into plus, it is minus half log of z plus 3 plus c. I'll take half common, it will be 1 by 4, within bracket log of z plus 1 minus log of z plus 3. Now then I'll apply the property of logarithm. Log m minus log n is log m over plus c. And the answer should be in terms of substitution quantity, that is in terms of x. Z equals to x square. Now then I'll substitute x square plus 1 over x square plus 3 plus c. This is your final answer, the method of substitution. Now this was for today, dear student. Now some more questions I'll solve, then I'll send it to you and try to understand all the questions. Okay, remaining question I'll solve and send it to you in next video, that you'll get another form of partial fraction. Thank you.